Alright, so in this video we're doing vertical projectile problems. Now we're doing the graph types problems, whereby you're given the graph instead of you being asked to draw it. So in this case, please pay attention, and before we begin, please, if you like this video in the beginning, just do like it. Alright. So now let's begin. We have a question statement at the top, and yeah. So a boy stands at the edge of a high cliff, right? He throws a stone vertically upwards with an initial velocity of 10 meters per second. Good. Now the stone strikes the ground at a point below the cliff after 3.5 seconds. Now the velocity time graph below was obtained from measurements made during the motion of the stone, right? Good. So the first question you should ask yourself before solving this, you have to ask yourself this: is the direction, what is the direction or the motion of the ball? Is it upwards or downward? Did it take upwards as positive or downwards as negative? What is happening, right? So remember this: they said the boy is standing or stands at the edge of a cliff, and now he throws a stone vertically upwards. So remember what I said in the introduction of the video of this playlist. I said something important, that if when a ball is thrown upwards, the velocity goes downwards. So what is said here? It is projected upwards by 10 and the velocity has to go down. So this means that all of our calculations, upwards is positive. You were forced to use this one. This is the direction at which they took to be positive in this graph. That's the first thing that everyone gets to falls into, right? You have to understand which direction of the motion the ball was thrown, right? Good. Now we can begin. They asked us calculate the acceleration of the stone between time 2 and 3 seconds. Now someone may be like, oh, sir, isn't it 9.8 meters per second? Oh no, I don't know. We have to confirm first. Right, so here's how we're going to confirm. Remember, the gradient of the velocity time graph is acceleration. Why? Here's why. Since acceleration is defined as the change in v over the change in t, right? So that's how acceleration is defined. And here's why. This is the y-axis, this is the x-axis. In maths, we define it as y2, y1, x2, x1, right? I hope someone, now you see what I mean. Good. Now let's begin. So they said for us to, let's see, to find the gradient of, no, they said calculate the acceleration of the stone between these two. So I know that my gradient is acceleration, change in v over the change in t, of which then I could say this, sorry, change in t, I could say the change in v is what? At 2 seconds. So this is 2 seconds. Let's see, this is the first one, it is 10, negative 10, and at 3 seconds it is what? It is negative 20, right? Negative 20. So here's how my velocity, it's going to be negative 20 minus negative 10 divided by the times you were given, which is 3 minus 2, right? And at top it's going to be a plus, so you should get negative 10 divided by 1. Therefore my acceleration is negative 10 meters per second. Now for someone who's like, oh, isn't it always 9.8? Yes, it is, but remember, it is 9.8. Now if you round off this, gives you 10. So that's why they basically just said 9.8 meters per second. And you also have to write the direction. Say 9.8 meters per second, skirt down. You can even leave it like this, because it just tells the marker that, okay, it's downwards. Therefore it proves the theory of up is taken as positive in this problem. Right, moving on to 6.2. At which times is the stone moving at a speed of 5 meters per second? So they want you to give us the time at which the stone is moving, and at a speed of 5 meters per second. Now it can be positive or negative, they don't care, but just give us the time. Here's the time. The first time is this one, which is 0.5. So the first time it's 0.5 seconds. How did I find it? Now remember, this is 1, so the half of this line basically it's 0.5. So it's at 0.5 and where? 1.5 seconds. Right? Happy? Happy. Right, now 6.3. After how many seconds does the stone reach its highest point? Meaning the maximum point. After how many seconds does the stone reach its maximum point? Now remember what we have been preaching. When the stone reaches its maximum point, the VF is 0. So the velocity, you have to look for the point whereby the velocity is 0, which is here. Therefore, after 1 second, did the ball reach its highest point? Right? Hope everyone is following along. Now, let's move to 6.4. 6.4, determine the height of the cliff which the stone was thrown. So they want you to determine the height of the cliff. How can you do that? Now you know the V, your V initial is what? Your V initial basically it's 10. You have that one, right? You have the V initial, it's 10. And let's see, what else do you need? You do know your final velocity, it's 25. It's 25 since we take up as positive, so it's just going to be what is it? It's going to be 25 and stuff, yeah. It's going to be negative 25 since we took up as positive. Basically they gave it to us like that. And yeah, and what else do we know? We know that our acceleration is negative 10 meters per second, and we're looking for what? For the change in y. So you can just calculate it like that and say vf squared is equals to the v squared initial plus 2a change in y. And from there on, the v initial basically is going to be 10 squared plus 2 negative 10, and your change in height that you're looking for on the negative 25 on this side. Right, then after doing your calculations, you should get 26.25 meters. So this is the height of the cliff. Now for some, they can actually find the height of the cliff. You can find it basically without the use of calculations. You can just assume or use the area, right? You can use the area of this thing, right? So basically here's what you're going to do. You're going to use the area of a triangle, right, to find basically the height, the change in y. The height of the cliff, it's defined with the area of the graph. So the area of the graph, you just need to find the area under which it is. So basically you are going to say 1 over 2 and say 10 multiplied by what? By 25. Remember that there's no such length that is negative, right? And then after doing that, you are going to multiply it by 1.5. Then you should get 26.25. And then you're done. Right. So, but then please just use the calculations, and I think you should be safe. Yeah, you can use the area for those that are questioning me, asking, okay, what is happening? You can use the area, and then yeah, good. The area of a what is this area of a trapezium? Yeah, area of a trapezium, area of a triangle. You can use those ones. You're more than welcome, but I feel like you should use the calculations, the one that you're used to, and I think it will be much easier for you. Now let's come to the last one, which is 6.5. 6.5 is using the top of the cliff as the initial position of the stone. Sketch the position time graph for the motion of the stone from its highest point until it reaches the ground. Oh wow. So they want us to draw the position time graph. Only indicate relevant time values on the x-axis. Good. Okay, let's come here. So here's how I'm gonna draw mine. Since I know that up is positive, here's how. It basically, the position time graph, it's quite easy because it describes the motion, or the basically the position or the motion at which the stone underwent, right? So we're gonna begin it here. It starts at 0, which is the change in t, and the change in ym. Yours will be much cleaner and better than mine, right? So you can look here, the relevant information is at 2 seconds you're still going down, and up until where did it stop? It stopped at 3.5, right? Okay, so basically the stone, it went up and reached its maximum point, which is here, and then now it went down and then down, which is still at 2, and down up until 3.5. Is that hard? Right, so it's just going to be from this point going down and down and down and down and down and down, and then yeah, this is 2, this is 3, this is 4, and this is what, this is 1. Then you're done. Just like that, you would get a mark for this one or this one, and yeah, and then you're done. Remember that this is the position time graph, so it's not the velocity time graph, whereby when the velocity is 0, it's at its maximum point. So here we know that it's at it's not the maximum height or anything, it's just the position at which the ball was at time 2. So guys, I hope you understood this one. It was a quite interesting one. This is the type of problems that you can expect in the examination, the graph type vertical projectile. Hope you enjoyed it, and guys, I'll see you in the next one.